All right. This is part 2 of solving paper 1, variant 2, 2026. Question 21. When concentrated sulfuric acid is added to catalyst, to crystals of sodium chloride, the products include a colorless gas, and a brown colored substance. The colorless gas gives a cream precipitate when AgNO3 is added. So if we look at the first reaction, concentrated sulfuric acid is added to sodium bromide. We know that when sulfuric acid is added to sodium bromide, sodium hydrogen sulfate and the hydrogen bromide are formed, and the hydrogen bromide is a colorless gas. Okay, then the colorless gas, which is hydrogen bromide, when we add to silver nitrate, we know that silver bromide is formed, which is a cream precipitate. So which row describe the reaction that produces the colorless gas and the brown colored liquid substance? Okay, so the first reaction is sulfuric acid plus NaBr. It gives NaHSO4 plus HBr. طبعا we know that this reaction is acid-base reaction. And the second reaction, which is HBr plus H2SO4, that produces Br2 plus SO2 plus H2O. This reaction is a redox reaction. Why? Because sulfuric acid is oxidizing agent and the hydrogen bromide is reducing agent. Okay, so this is why the reaction continues until it forms a bromide. And you know that HI is a stronger reducing agent, so the reaction can go further and it can form S, and it can form H2S and I2 as well in case of HI. Okay, so the first reaction is acid base and the second reaction is redox reaction. Okay, and don't forget that the reaction that produced the colored, the brown colored substance is this one. HBr plus H2SO4 gives Br2 plus H plus SO2 plus H2O. Okay. Question 22. X and Y are halogens. The following reaction occur in an aqueous solution. NaX plus Y2 give NaY plus X2. And this will never happen if X is less reactive than Y. So this reaction to happen, Y should be more reactive than X, so that Y can displaces X. Okay? Right. In this case, we have chlorine and bromine. Which one is more reactive than which? So we know that chlorine is more reactive than bromine. So X should be a bromine and Y should be chlorine. X should be Br and Y should be chlorine. Okay? In this reaction, X, which is bromide, is converted into Br2. So if you look at the oxidation state or oxidation number, it changes from -1 to 0. So oxidation happens. Since oxidation happens, so the bromine has oxidized. The bromine has oxidized, so it acts as reducing agent. And in the same time, Y, it was 0 and become -1. So Y is reduced, so it can act as oxidizing agent. Okay, so X is bromine. The answer is A or B. Y is chlorine, and NaX act as reducing agent since bromine has been oxidized from -1 to 0. Question number 23. More salt is a pale green crystalline solid, okay, which is soluble in water. It contains two cations and one of which is iron and one anion is sulfate. So the other cation, I don't know. The second cation is unknown. The identity of the second cation can be determined by heating the Mohr salt with aqueous sodium hydroxide. And you know that adding sodium hydroxide is test for cation. A colorless gas was evolved that readily dissolve in water giving alkaline solution. The gas that dissolves in water to form alkaline solution is ammonia. Since ammonia is produced in addition of sodium hydroxide, though the cation is ammonium. The cation is ammonium. To make sure of this, a green precipitate was formed also. The green precipitate was formed also because the salt contain iron and ammonia. So when we add sodium hydroxide, green precipitate formed because iron aqueous reacts with the hydroxide, which is aqueous, to form iron 2 hydroxide. This is the green precipitate. So the Mohr salt contain. So Mohr salt contain iron 2, contain ammonium, and contain SO4. So it's called ammonium iron 2 sulfate. Ammonium iron 2 sulfate. So the gas is ammonia, and the green precipitate is FeOH2. The amount of each gas, question number 24, the amount of each gas in the exhaust gases from the internal combustion engine, is determined. The exhaust gases are passed through the exhaust catalyst known as catalytic converter, which statement about the effect of catalytic converter are correct. In the catalytic converter, we know that NO react with CO, nitrogen monoxide plus carbon monoxide gives N2 plus CO2. This is what happened in the catalytic converter. So the amount of nitrogen gas increases, yes, because nitrogen gas is produced. The amount of carbon dioxide gas decrease, this is wrong, because the amount of carbon dioxide gas increase because it's part of the product. The amount of carbon monoxide doesn't change, no, the amount of carbon monoxide decrease. The amount of carbon dioxide decrease as it is consumed in the reactant. So the answer is only number 1. Question number 25. In this reaction, alkenes and cyclic alkanes should be considered. Alkenes, C double bond C, cyclic alkanes like cyclobutane or cyclopropane or cyclohexane and so on should be considered. How many structure isomer of C4H10? C4H8. On C4H8, the normal structure that you can make from the open chain is but1ene, and but1ene. We can make also but2ene, and we can make methyl propene. These are the open chain isomers, okay? And also we can make cyclobutane, yes, this one, or also we can make methyl cyclopropane. All of these, if you count the number of carbon and the number of hydrogens, they will be C4H8. Here we have 1, 2, 3, 4 carbons, and each carbon contains 2 hydrogens, so it's C4H8. The same here. This carbon contains 2 hydrogen, this carbon contains 2 hydrogen, this carbon contains 1 hydrogen. So 2 plus 2 plus 1, 5 plus 3, 8, and we have 4 carbons, so it's also C4H8. And of course, you know that this one is C4H8 and butene is C4H8. So the number of isomers that we have are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 isomers. Which pair of molecules are positional isomer? Positional isomer, yani I will change the position of the substituent or the position of the function group. So the first one is this one. This one is butane, and this one is methylpropane. This is chain isomer. And this one is 2-chlorobutane, and this one is 1-chloroputane. Yes, these are positional isomers because I changed the position. Positional isomers because we changed the position of the double bond. The position of the chlorine. Here, this one is function group isomer because this one is butanal. This one is butanal. As you can see here, this one is butanal because aldehyde group is the function group. And this one is butanone. This one is butanone, so it's function group isomer. Here, this one is but1ene because the double bond exists here between this carbon and this carbon. This is sorry, this one is but1 because the double bond exists between this carbon and this carbon. And this is also but1 because the double bond exists between this carbon and this carbon. So both of them are the same molecule. So the answer is B. Question 27. The reaction sequence shown takes place in 2 stages. Stage number 1 is concentrated sulfuric acid. So in stage number 1, to add concentrated sulfuric acid, this is dehydration. So we will remove water molecule and the compound changes into alkene. But if you notice that in this one, it was open chain. And if you notice that this one here, if you notice this part, the cycle here, this cycle is open, but this one is closed. This means that the elimination of water, it leads to a closed cycle. Okay, so and these parts are the same. This part is the same as this part, and the rest, which is this part, is the same as this part. So the only change is here. Here is the only change. Okay, so to make these changes, or to make this change, it's better to make this group, instead of cis, make it trans. Yeah, make it like this, OH here. So I can take OH here and I can take H from here. Okay, when we take this H and this OH, this chain will be closed. As you can see here, this chain will be closed. So this reaction is a dehydration, and you know that dehydration is a type of condensation reaction because it condenses the chain and make it closed. Okay. And the stage number 2, if you look at stage number 2, we have here double bond, we have double bond, we have double bond. Every double bond, and this double bond, the first one, this one, changed into 2OH. Okay, this one changed into 2OH. Okay, and this one as well changed into 2OH. So this is an oxidation with amine conditions like cold KMnO4. Okay, so if you want to answer the question, stage number 1, of course, it's not reduction because we remove a molecule of water. It's not reduction. So number 1, B and D are wrong. So it should be condensation. But condensation and hydrolysis, no, it's not hydrolysis. It's an oxidation. So the answer is C. Okay. 3 halogen, question number 28. 3 halogenoalkane are listed. 1 bromopropane, 2 chloropropane, and 1 bromo, 2 chloropropane. Okay, but which of these halogenoalkane could be produced when propene, which is CH3, CH double bond, CH2. Propene reacted with a mixture of HCl and HBr. Propene consists of only 1 double bond, so only 1 double bond will be broken. So only one of them can be added to propene. So number 3 wrong. We can't add bromine and chlorine in the same time because they are not, because we have only 1 double bond. So the answer is, do we have 1 propene and chloropropane or not? Let's do the reaction to know the result. Okay. The first reaction we have here, 1 chloropropene. We have propene plus HCl. We will break this double bond. And we will add H and Cl to this carbon and this carbon. According to Markovnikov, H is added to the carbon rich. So H will be added to this carbon, and Cl will be added to this carbon. So it will produce 2 chloropropane. And in this case, this product is the major product. The minor product is 1 chloropropane. If the chlorine is added here and H is added here, this is minor product. So in the first case, the major product is this one. Okay. Also in the second case, HBr, if you add HBr, you will break the double bond, and Br will be added here and H will be added here. This will be the major product. this will be the major product. Okay, this one will be the major product, and this one will be the minor product. So the major product will be 2-bromo, and here the major product will be 2-fluoro. Okay, and 1-bromo is the minor product. So I have here 2-chloro, which is the major product of the first reaction, and we have here 1-bromo, which is the minor product in the second reaction. Right. According to the question, the answer could be D or B. D, because in the first reaction, the major product is 2-chloropropane, yes, and in the second one, 1-bromo is the minor product, so it is produced in a very small amount. Which one of them do you choose? The answer is in the question itself, because he said could be produced. Could be produced, يعني the probabilities, يعني write the whole probabilities. So this one is one of the probabilities, and this one, even if it was minor. And the second one is one of the probabilities, even if it was, طبعا this one is the major one. So the answer B. Question number 29, 2-bromo methyl propane is heated with concentrated NaOH. On this is halogenoalkane, right? 2-bromo methyl propane is this one. Okay? Halogenoalkane. This is tertiary halogenoalkane. Added to sodium hydroxide in ethanol. طبعا sodium hydroxide, you know, if we add sodium hydroxide, aqueous, it's electrophilic substitution reaction because we add OH. But if we add it in ethanol, this is elimination reaction and we produce alkene. So in NaOH aqueous, it produces alcohol, and NaOH in ethanol, it produces alkene. So here, to produce the alkene, we will remove this Br and one of these H's, and both of them are the same. So we will remove this one and one H from here. So we will get this compound. This compound is methyl propene, 2-methyl propene or methyl propene. So methyl propene is produced. So the answer could be 1 or 2, or A or B. Okay. Methyl propene is produced in the elimination reaction or condensation reaction. طبعا it's an elimination reaction. So the answer is A. Question 30. Which reagent could be in ethanol? Question 30. Which reagent react with ethanol? Ethanol is an alcohol. طبعا alcohol react with sodium. It reacts with SO. Cl2 react with PCl5. This is a direct question. The answer is 1, 2, and 3. 3 alkenes are listed: hex-1-ene, cis-hex-2-ene, and trans-hex-3-ene. Which alkenes can be formed by the dehydration of hexane 2O? This is hexane 2O. This one is hexane 2O. Okay? OH exists on carbon number 2. This is hexane 2O. If we make dehydration, if we take OH from this carbon and H, if we take OH from here and H from here, so the double bond will be formed here. Okay. In this case, we will form hex-1-ene, right? Hex-1-ene, and this one doesn't contain cis and trans because the first carbon contains 2 hydrogens, 2 similar groups. Okay. So hex-1-ene is one of the product. And if we take OH from here, and the H from here, it will form hex-2-ene, right? But hex-2-ene can be cis and trans. Why? Because we have on this carbon we have hydrogen and alkyl, and on this carbon we have hydrogen and alkyl. So it can form hex and trans. And of course, hex-3-ene cannot be formed, so the answer is 1 and 2 only. Question 31. Which compound would give a positive test with alkaline I2? طبعا alkaline I2, it searches for CH3CO or CH3 CH2OH. Okay, since in the choices we don't have alcohol, so we are not searching for this, we are searching for this. And with Fehling, this means that it should contain aldehyde group. So this compound should contain CH3CO and aldehyde group. This one doesn't, it contains aldehyde group, but it doesn't contain CH3CO, so this one is wrong. Also, this one, it doesn't contain aldehyde or CH3CO, so this one is wrong. Here, this one, it contains CH3CO, this one, but it doesn't contain aldehyde group, so this one is wrong. So this one is right because it contains aldehyde group, which is this one, aldehyde group, CHO, and it contains CH3CHO, which is this one. So the answer is D. Question 33. A compound Y is heated with amide oxidizing agent. One of the products of the reaction reacts with a hydrogen cyanide, forming 2-hydroxybutane nitrene. 2-hydroxybutane nitrene. So first, it reacts with mild oxidizing agent, then it reacts with HCl. Okay, but But1-ol, let's take it every choice. But1-ol, if you make it a mild oxidation, it will form butanal. Alcohol becomes aldehyde. And if you form, if you add HCl on 2-hydroxy on butanal, okay, it will form this compound, which is 2-hydroxy, 1, 2, 3, 4, 5 pentane nitrate. 2-hydroxypentane nitrate, because you know when we add HCl, we add an extra carbon. We know that nitrate increases the number of carbons. Okay, so instead of butane, it becomes pentane. And the same for this one. For this one also, But2-ol, if the OH exists on carbon number 2, so the oxidation gives ketone. And if you add OH to the ketone, so it will produce this compound, which is 2-hydroxy, 2-methyl butane nitrate, 2-hydroxy, 2-methyl butane nitrate. For propane-1-ol, mild oxidizing agent, it gives the propanal, this compound. If you add HCl, so OH will be added on the second carbon and Cn will be added to the whole chain. So instead of but, it will be, instead of prop-1-ol, it will be butane, it will be 2-hydroxy, butane nitrene, 2-hydroxy butane nitrene. Okay, so the answer is C. Okay, طبعا this one doesn't form 2-hydroxy butane nitrene. Okay, an ester of structural formula CH3CO2CH3 is heated with aqueous sodium hydroxide. So this one is heated with aqueous sodium hydroxide. And this one, it's ester. It's methyl ethanoate. This ester is methyl ethanoate. And when we make hydrolysis of methyl ethanoate, it gives methanol and ethanoic acid. We will break from here, and it will form methanol, and ethanoic acid. Okay. Fine. In the presence of NaOH, acid can react with NaOH to produce sodium ethanoate. It will produce sodium ethanoate and methanol. So the final answers are sodium ethanoate and methanol. طبعا alcohol doesn't react with sodium hydroxide. Question 35. A student suggests 2 uses of LiAlH4. طبعا you know that LiAlH4 is a strong reducing agent. It can reduce carboxylic acid to alcohol. Okay, but we didn't take that it can reduce alkene to alkene, because if you remember, to change alkene to alkane, we just add H2 in the presence of nickel, at 150 degrees Celsius, we can change alkene into alkane. But LiAlH4, it's not a reducing agent in this case because of the presence of the pi bond. Reaction number 2, this is ethanoic acid. Ethanoic acid in the presence of LiAlH4, it can produce alcohol. This is normal. So reaction 2 can happen. Which reactions would give the product shown? Both reaction 1 and 2 wrong. Reaction 1 only wrong. Reaction 2 only correct. Okay. The diagram shows the reaction of an addition polymer. This is addition polymer. What is the name for this polymer? To know the name of this polymer, we have to know the name of the monomer. To take the monomer, just take the first part, this one, the first 2 carbons, and just add the double bond here. So this is the first 2 carbon, okay? And just add the double bond. When you add the double bond, the name of this compound is 1,2-dichloroethene. 1,2-dichloroethene. So the name of this compound will be poly 1,2-dichloroethene. So this will be the compound. Come on, it's not 1,2-dichloroethene. Like when we make a polymerization of ethene, it forms polyethene, right? When we make polymerization of ethene, it forms polyethene. So when we make a polymerization of 1,2-dichloroethene, it will form poly 1,2-dichloroethene. Okay? 0.2 mole of P react to form 7.83 grams of primary amine. Okay? The percentage yield is 0.45%. Which row is correct? طبعا you know that to form a primary amine, we have to react the primary alkyl halide with ammonia. Primary alkyl halide with ammonia, like CH3, CH2, for example, CH2Br, bromo, propane. If you react with NH3, it forms a primary amine like CH3, CH2, CH2, NH2. So this is a primary amine. Okay? Right. So the conditions of this reaction is we need ammonia in ethanol. We need ammonia in ethanol. So I need primary amine and I need ammonia in ethanol. So, so the A and B are wrong because the condition is not there. Lower NH3 in ethanol. So C and D could be the answers. But C, this is halogenoalkane, but is this primary halogenoalkane? No, it's not primary halogenoalkane. It's secondary halogenoalkane. Okay, or secondary alkyl halide. So C is wrong, so the answer is D. So why he gave us all of these information? I can answer without this information. I can answer the question without this information. The answer is D. It couldn't be A or B or whatever because they will produce different reactions. Okay? But to make sure about D, we can, to make sure that D is correct, we can use the percentage yield. The percentage yield, equal the actual over theoretical. Okay? Type. Here is the actual yield produced. Okay? And we have the percentage. So I can get the mass of the theoretical yield. How? Just divide the actual over the percentage. You will get the theoretical yield. So the theoretical yield is 17.4 gram. This 17.4 gram represents 0.2 moles. So the 0.2 moles, their mass is 17.4 gram. I need to get the MR of this compound. Okay, the MR. So the 1 mole gives the MR of the compound. The MR of this compound equal, I know that MR equal mass over the number of moles. Mass over the number of moles. We will get that the MR is 87. The MR is 87. We excluded C, we excluded A and B. Let's apply this on D. Let's apply this on D. طيب. D D, if you find the MR of this compound, if you find the MR of this compound, the product of the reaction, this one will be CH3, CH2, CH, CH3, NH2. You will find that it's C5H13N. But if you find the number, the MR of this compound C5, يعني 5 times 12 plus 14 plus 13 plus 14 for N, there will be 87. So this is the MR of the compound. It's the MR of the compound. Okay? Okay? So the compound is as I said, we don't need the percentages and these calculations to the answer. The answer is direct, is D, because it's a primary alkyl halide and the conditions are correct. 38 bromine react with ethene in dark. Bromine react with ethene. طبعا this is electrophilic addition, right? Electrophilic addition reaction. The electrophilic addition reaction, which description of the organic intermediate of this reaction is correct? طبعا this is the mechanism of the reaction. We have here, as you can see, we have here the double bond, and we have here bromide partial positive, and this one is partial negative. The double bond here attacks this bromide, which is partial positive, and this lone pair will be carried on this Br, so we'll have Br has lone pair and it has negative charge, and this Br will carry it on one of the carbon, and the carbon will be the carbocation, and this is carbocation, and then the Br can attack this carbocation to form dibromoethane. So the description of the organic intermediate of this one is an electrophile. Okay. Question number 39, when one bromopropane is treated in succession with two reagents, X and Y, it produces propanoic acid. One bromopropane, this one bromopropane, when we add sodium hydroxide aqueous, as we said, it produces alcohol, right? If it is in ethanol, it produces alkene. So it produces propanol, propane, whole, or one propanol, okay? If the one propanol undergoes oxidation with a strong oxidizing agent, it converts from alcohol into carboxylic acid, okay? So to produce propanoic acid, the first step, we have to put sodium hydroxide aqueous, and the second step we have to make oxidation by strong oxidizing agent. One, the first one is the answer because it is NaOH aqueous and acidified potassium dichromate 7. This is the answer. One, the second one is wrong because carbon dioxide will not oxidize propanol into propanoic acid. The last question. An organic compound X has the composition shown. C is 54.54, H 9.09, and O 36.37. The infrared spectrum of this compound is this one. If you want to read the infrared spectrum, this one about 3000 is for CH, and this one about 1720. This one at about 1720 is for CO, and this one about 1250 is for C single bond O. So 1720 C double bond O and 1250 is C single bond O. What's compound X? Compound X, it couldn't be acid because if it is an acid, we should have a broad band at this range. Okay, we should have a broad band of O for OH at this range. So since we don't have this, so the first two answers are wrong. But the second two answers, ethyl ethanoate or methyl methanoate, both of them are ester. And both of them contain C double bond O and C single bond O. So this one and this one exist in both of them. To know which one is correct, we have to use these calculations to find the empirical formula of the compound. Okay? طيب CHO 54.54, 9.09, and 36.37. Divide by 12, divide by 1, divide by 16. You will find 4.545, 9.09, 2.273. Divide by the smallest number, which is 2.273. So it will be 22421. So the empirical formula will be C2H4O. And C2H4O is not an ester. So to make the ester, at least we will multiply this by 2. We'll multiply this by 2. When we multiply by 2, it will be C4H8O2. C4H8O2, they can be one of the two esters. They can be this ester, which is CH3CO, CH2CH3, which is ethyl ethanoate, and it exists here, so this one is correct. The other one is CH3CH2COO, CH3, which is methyl propanoate, which is not given, so the answer is C. D is wrong. D is wrong because methyl methanoate is HCOOCH3. This is methyl ethanoate. So the molecular formula is C2H4O2. So the empirical formula is CH2O. This empirical formula doesn't match this empirical formula. So the answer is not D. The answer is C. And this is the end of the exam. Thank you. Good luck. So